I'd now like to walk through example 2 in section 9.2, and I'm on page 587. So looking at this example, it is saying, like the one you just did, giving us a highlighted direction and the ones that are coming up, identifying and graphing a polar equation, and then it says in parentheses line. You're just going to have to practice, watch, think, reason out, and get these to make sense to you. Like right here, it says identify and graph the equation, and it gives us the equation theta equals pi over 3. And so in my mind, I like to think of what makes sense. And so theta equal pi over 3, as we go look at the drawing, my brain may not automatically think about this bottom part, but if I know we're talking about a line, and our line is that theta equals pi over 3, that blue part makes sense to me, that is a 60-degree angle, and that I can draw that blue line. Where I have to expand my thinking is to realize that all of that line is going to equal the theta equal pi over 3. But they give us directions, and they're going to ask us to do multiple things, and one of those is to convert this polar to a rectangular. We're starting with this theta equal pi over 3, and right here it says find the tangent. So I've written in a note to add to your skills to try. Earlier we saw where we might want to square both sides, or we may want to multiply both sides by r. Most of what we're doing is revolving around tangent because we have the y and the x. And so one other trick you need to add to your bag of tricks is to have the ability, the permission, to tangent both sides. So I'm going to tangent the theta and tangent the pi over 3. And when I do, if I remember I'm going to rectangular, I'm trying to get to x's and y's and a bunch of numbers. X's, y's, and a bunch of numbers. And so if I look right here, my tangent theta, well, it is y over x. Well, bingo. I'm now not with a theta, I'm now with x's and y's. And on the other side, tangent of pi over 3, and I actually started writing it down here, tangent of pi over 3, and that's not very clear, so I'll stay right here. Again, tangent of pi over 3 is the square root of 3, and then if we're trying to make this look like an equation in the rectangular coordinate system that we're used to seeing, we can multiply both sides by x, and the resulting equation will be what you see right here. Y equals, and I like to write it where my x is out front and my square root of 3 is behind. I don't like how they've written it because sometimes that x can be confused as to whether it's actually under the radical or not. This is fine. I prefer this one for clarity, but this one is like y equals mx plus b, so that it has a y-intercept of 0. So have we done everything they wanted us to do? We're graphing it, convert it, all of these things, because now we could take this equation, we could do a chart, probably a chart, or we could plug it into something, a computer or calculator or an online program, and it would graph this when we picked values for x, multiplied them times square root of 3, and we would get our y coordinates. And if you can envision this as an xy coordinate plane, every point that we would graph is going to land on that blue line that you see there. The last thing I'd like to point out is that the y does equal mx plus b, and it does go through the origin if our b is 0 and our b is 0.